This is a pretty early version of a program I wrote called Dante Dials, so far, that is basically an interactive instrumentation cluster for pretty much any car. The goal is to get it to run over the CAN bus, which most modern cars support. So you'd be able to read inputs and have them presented in a visually appealing way. It's totally configurable and also scales to like any size of display. So what we've got here is a graphical provider I've written called Dante Graphs, which is designed to look exactly like the graphs and instrumentation in a Fiat 500 from the mid-70s. So this is our second page here, which has a digital clock module you can see up there. It's got a dial running a sweep input, which you can actually just match any input to any dial, or even a bar graph, for instance, as we have on the first page. We've got a bar graph here, a line graph, and a mixed input line graph. Over here, we've got current frame rate. It's locked at a steady 30 frames a second, which is generally going to be like a great refreshing rate for something like this, because you're not going to run into too many hardware issues. It's going to have like a lot of spare CPU time, but you're also going to have it match up with most displays' refresh rates, which means you're not going to see any screen tearing or issues. It's just going to look like an actual dial as much as a computer can. You can change the background however you want. So if you want it to match the color of your dashboard or some other color in your car, of course you can do that. There's a little light up there, which will always stay off, as the label says. But that's a demo of the lights themselves. The graphics, everything here can be configured by developers or yourself if you're going to be adventurous, to match the look of a specific car or just to have a specific theme in mind. So as it stands right now, we're kind of just fitting a screen into a hole in the dashboard from the ashtray, but we're going to 3D print off a bezel and some kind of system to make it mount nicely. But this will be somewhat like what the final position will be. In terms of how I actually designed it, it's written in Python using the Pygame library, because I knew it would be relatively easy to design graphics in it. As I said, everything's scalable, which means that I had to do a lot of extra work to get that done, but I'm very glad I did. All the text, all the elements will scale to the resolution of your screen without being transformed in a very ugly way. It's running on it's not Raspberry Pi anymore, it's Raspberry Pi OS, which is a Linux, which means, it's great for performance on an embedded device like the Raspberry Pi that we're running here. You can add as many pages as you want, you can add modules, and everything is controlled in these examples with the module I wrote called spread, which basically will take any amount of modules in either vertical or horizontal orientations and spread them out evenly or unevenly. So, for example, to build this, we could have a horizontal spread. The module on the right would be taken care of by that single spread, but then another spread here, a vertical one, to spread out these two modules vertically. So I think that's possibly the most simple way I could make it so that you can configure anything you want. Again, it's very simple. So this has been a bit of a quick tour of the Dante Dials app as it is so far. We're planning to add a couple more features. I really want to kind of rework quite a bit of it so that we have polling rates for sensors, especially in something like graphs. That would be really important so that you can see exactly what happens every second. And at some point in the future, we'd also love to include an app so that you can do things like look at your converted EV's battery level, or how much charge it has, without having to go into your car and actually look at those details yourself. But yeah, just stay tuned for updates on it. We're certainly going to be working on it for a while, and we'll see you in the next video.